All right, I'm recording here. Calculus, new calculus. I need your attention, Mason. Ready? Good. Here we go. All right. So the Pythagorean identity is an identity. It's back there on the wall. If you're in this classroom, it says see it in there in the purple-ish and green. Right. So I won't go over where it comes from right now. We'll just say that it is this. Okay. Just very quickly, we know the unit circle and any spot on the unit circle. It has two coordinates, right? It has an x coordinate and a y coordinate. And what's the x coordinate? Yeah, the x coordinate is the cosine. So this point is over this far, and you really don't need this, but that's the cosine right here. What's the y coordinate? The y coordinate's the sine. And then if I complete this triangle like this, I just made a right triangle, right? And on the unit circle, what's the radius? I handed it out to you. What's the radius on the unit circle? Yeah, it's 1. So if you use the Pythagorean theorem, you get sine squared plus cosine squared equals 1 squared, which is 1. And that's where the theorem comes from. Okay? So anyway, we're going to use this, and we're going to use a clue that they give us. They're also going to tell us that the angle is in a certain quadrant, which is going to tell us about the sign, whether it's positive or negative. Okay? And we have to figure out what the sine ratio is. All right, so here we go. We don't know what the sine is, so we're going to leave that alone. But we do know that the cosine of theta, this little 1 really doesn't mean much. They're not giving us two angles, so I'm not sure why they did that. The cosine of theta is negative 12 over 19. But remember, the identity comes from the Pythagorean theorem, so that part is squared. So from here, all we have to do is solve. All right, now my advice to you is leave this as a fraction. Don't turn it into a decimal. Okay, how do you square a fraction? Yeah, and how do you do that? Yeah, top and bottom, right? So another way to do it is just square the top, square the bottom. Yeah, in effect, it's the same thing. Every kind of number squared is, every real number squared is positive. So we have 144 over 19 squared. (19 squared). Calculators. 19 squared. What's that? 361. Now watch this little trick. Instead of writing 1 over here, why? Right, you can see what's coming next, right? I'm going to move this whole fraction over to the right-hand side. When I do that, I need a common denominator. Right, people? Okay, so let's keep going. So now it's going to say sine squared equals this subtracted. Now, when you subtract them, the denominators stay the same. You just subtract the numerators. So 361 minus 144. 217. All right, I believe you. And then one last step. Square root of both sides. So we see if we can figure out what the square root of 217 is. See if it's a whole number. And then conveniently, 361 has a square root because we got it by squaring a whole number, right? Wasn't that 19? What's the top?
14.73.
14.73. Okay, gotta get it. Let's not do that, though, right? That doesn't really work. So what we'll do is we'll probably just leave it like this. Okay, some of your calculators do that sort of thing for you. Others don't. If your square root doesn't simplify, I think you can just leave it as that. Okay? Now, back to the original question. One last thing. In quadrant two, so here's the whole question. Quadrant 2. Remember our quadrants. They're labeled counterclockwise because some psycho decided so, right? It also actually matches with the way we measure angles, right? It goes that way as we rotate positively. All right, anyway, quadrant 2 is up here. And in quadrant 2, the x-coordinate is negative. The y-coordinate is positive. Now, they're asking about the sign. Is the sign the x or the y? The y. So our answer is, here's why we have to determine. Because when you take the square root of a number, there are actually how many possibilities? You take the square root of a number, there are 2 possibilities. For example, if I ask you, hey, what number times itself equals 81? The answer in some situations could be positive or negative, right? So when we're solving this situation and we do this last step here, our answer could be negative, depending on what quadrant we're in. If it had said quadrant 3 or quadrant 4, anywhere down here, the sign is negative. 10-4. Okay, here's another question like this. I wanted to touch on this one because it looks kind of funky from the get-go. I want to remind you how to square this sort of thing. Okay, I'll let you pause and you guys can write it down real quick. All right, so same situation, same identity. It's almost like a formula. Sine squared right here. This thing squared. I'm going to go a little faster. How do I square this fraction? Well, you square the top and you square the bottom. What happens when you square a square root? The number stays the same. Square root disappears, right? Okay. So stays the same. How about the bottom? It's 4. Right? And then just as a little hack over here, I'm going to call this 4 over 4. Yeah? Okay. If I'm solving this, I'm going to move 3/4 to this side. When I do that, I'm subtracting. So 4/4 minus 3/4. We got 1/4 left over. There's one last step. What's that step? Square root both sides. When you square root a fraction, you square root the top and the bottom. So, the cosine is, oh my goodness. Is either positive or negative a half. Which quadrant are we in? Quadrant 3. Let's go to quadrant 3. 1, 2, 3. Over here, the cosine is negative. The sine is also negative, right? So our answer is going to be -1/2. Now, this one, there's actually a shortcut right away. If you're right here, check it out. Where is the sign equal to -√3/2? It's on the unit circle. Check it out right here. Where's the sign negative square root 3/2? there and there. Those are the two locations where the sine, the y-coordinate, right, is negative square root 3 over 2. But it's in the third quadrant, which is here. So that one was actually present already if you familiarize yourself with the unit circle. The second assignment today is going to be unit circle stuff, and you're going to just identify these angles. Sorry, the cosine and sine from the unit circle. All right. That's all. Thank you.